Unit 3 is mass relationships and chemical reactions. So chemical stoichiometry is the main focus of this unit, the study of quantities of materials consumed and then produced in a chemical reaction. Now it's important to note that most AP essay problems are going to have some sort of stoichiometry to them. So it's a really important topic that you understand. Atomic mass is when elements occur in nature as mixtures of isotopes. So you take all of the isotopes, you average them together, you can get the average atomic mass. If we look at this question, it says which is a set of isotopes. Remember, an isotope is the same element but with different masses. So letter A would be inappropriate because it's not the same element. Letter B would be inappropriate because it's the exact same isotope. Letter C would be the answer because they're both boron, but they have different masses. D, again, is incorrect because it's two different elements. A mass spectrometer is used to compare different masses in a sample. The different masses hit the detector plate at different places. The smaller the E to M ratio. So E is the electrical charge, and M is the mass. So the smaller that ratio is, the wider the curve. So if we look at what a mass spec looks like, you have your sample and you inject it. It flies down the tube. You have a magnetic field which sends the atoms towards this detector plate. The least massive is going to curve the most, and the most massive is going to curve the least. And that's because it's heavier, so it's not going to curve as much. And then based on where they land and how many hit that spot, you can figure out the type of isotope that it is. Okay, so if we look at the mass spec for boron, it shows that boron has two isotopes, one with a mass of 10 and one with a mass of 11. And then if you look at the percentage, boron 11 is much more common than boron 10, and that's shown by having the taller line. So the y-axis shows you the relative abundance or the percentage. And this data makes sense if we look at the mass of boron on the periodic table. It's 10.811, which is closer to 11 than 10, so it makes sense that isotope 11 is more common. To solve for the average atomic mass, you look at all the natural occurring isotopes and you take a weighted average. So it's not 50-50 for lithium, because lithium has two isotopes. You have to take into account the abundance. So what you do is you take your mass. Now, even though we say it's lithium-6, it actually has a mass of 6.0151214. And that's because the actual mass of protons, neutrons, and electrons are not 1 and 0. So we're going to take our mass as specific as they give it to us, and we're going to multiply it by the percentage, but we want to take it out of a percent. So it's going to be 0.0759. In other words, you're going to divide it by 100. And we're going to add it to our other percent. So our weight is 7.0160030 AMU. And we're going to multiply it by 0.9241. Now with the sig figs, you typically just look at the percentages to figure out what the average atomic mass is. So in our first percentage, we have 3 sig figs. In our second, we have 4. So our answer we're going to write with 3 sig figs. So we'll say 6.94. And then the unit they gave us is AMU, or atomic mass unit. Now 6.94, if you look on the periodic table for lithium, the average atomic mass is 6.94. So that's kind of proving it. Now, because you have a periodic table, on all parts of the test. They typically just use element X, so you can't just look on the periodic table to see if you're right. The other way that they word these questions is they tell you the element, lithium, so that you know what the answer should be, 6.94, and then they ask you to solve for one of the masses. One thing to keep in mind is that percentages should always add up to be 100. So if they don't give you any information about lithium-7, you would still be able to know the percentage because you can subtract from 100, and then you can set up your algebra with an X here for the mass and solve for X. The mole is the number equal to the number of carbon atoms in exactly 12 grams of pure carbon-12. So 1 mole is equal to Avogadro's number of anything. Moles or atoms, molecules, ions, or particles. You could also have a mole of elephants, and you would have Avogadro's number of elephants. The molar mass is a substance's molecular weight. It's the mass in grams of 1 mole of the compound. Now, covalent things have molecular formulas. They have molecular units. So instead of molar mass, you might see molecular weight. Ionic compounds have a formula mass instead of the molecular weight, and that's because ionic compounds are made out of ions and don't have that molecule unit. So just keep in mind that molar mass, molecular weight, formula mass are pretty much the same thing. You're just talking about little technical differences. So to find the molar mass, you're going to add all of the masses up off of the periodic table. So for calcium phosphate, you would do 3 calciums, 2 phosphoruses, and 4 oxygens. And you should end up with a molar mass of 310. Now if you do sodium, hydrogen, phosphate, 2 sodiums, 1 hydrogen, 1 phosphorus, and 4 oxygens, you should end up with 142. Alright, and then we have our simple conversions. So always remember that the molar mass is 1 mole, and that 1 mole is Avogadro's numbers of whatever it is that you're talking about. So if we want to calculate the mass in 50 or 500 atoms of iron, where would we put our numbers? Alright, so 1 mole of iron would go on the top. 500 atoms of iron is what we start with. One mole of iron would go on the bottom. 56 grams of iron is the molar mass of iron, so that's what we want to end with. And then we have Avogadro's number. So remember, these types of problems are always on the AP exam. You need to show all of your units, so you should have a number, a unit, and a substance, and then they should cancel out so that you're left with what you're looking for. So if you multiply and divide, you should have an answer of 4.65 times 10 to the negative 20th grams of iron, a very small mass. There was 3 sig figs in our given, so there should be 3 sig figs in our final answer as well. Do try and get in the habit of boxing in or circling your answers as well.